Let's talk about solving problems with algebra, solving word problems with algebra. In math and science, we define variables to represent numbers that we don't know the value of. It allows us to work with them even without knowing the value. To solve word problems, we set up equations using variables and numbers, then solve the equations to find the value of the variable. An expression is a mathematical expression that consists of variables, numbers, and operations. The value of this expression can change. So an example of that would be 5x plus 2. An equation is an equation in the form p equals q, where p and q are polynomials. So basically we have, the only difference between the two would be the equal sign. 5x plus 2 equals 20. Write each of the following as an algebraic expression with one variable. So quickly going through, 3 times a number, that would look like 3x, or 3 times x. A number increased by 4, a number increased by 4. Tara's age 2 years ago, so her age minus 2, or age 2 years ago. Twice the width increased by 3, so I'm doubling the width, twice the width, and then increased by 3, could look like 2w plus 3. So for all the following examples, we're going to make an equation and then use the equation to answer the word problems. So first example, 2/3 of a number plus 4 is 16. We need to find that number. So we're going to set our variables, let n be a number. So our variable we're going to use is n. 2/3 of a number, right? That's the same as saying 2/3 times a number, plus 4 is 16. So it equals 16. I'm adding 4 to it, and then 2/3 of that number. So the expression that I have, or pardon me, the equation I have is 2 over 3n plus 4 equals 16. Now we know from solving equations, I need to eliminate this denominator of 3, so I multiply this term by 3, and I have to multiply every other term in the equation by 3. I end up getting 2n plus 12 equals 48. I need to solve for n. I start isolating for my variable. I end up getting the n value to be 18. Example number 2. If 4 is subtracted from twice a number, the result is 10 less than the number. So now we need to find the number. We're going to say x is going to represent that number, or let x be a number. The key language in here, 4 is subtracted from twice a number. The result is, this is a key piece of information. That essentially means equals 10 less than the number, and that's the same number. So if I let x be a number, 4 is subtracted from twice a number, so 2 times a number, subtract 4, and the result is 10 less than that same number. So I ended up getting 2x minus 4 is equal to x minus 10. Now I go ahead and solve for my variable x. We know how to bring variable terms on one side, constant terms to the other, and I end up getting x is equal to negative 6. So more of a word problem. Mr. Skivington, operates a variety of stores with his sons, Jerry and Coco. Jerry makes twice as much money as Coco, who only works part-time. Mr. Skivington makes $200 per week more than Jerry. The total week payroll is $1,450 or $1,450. How much does each family member earn per week? So we're only going to be comparing it to Coco. So we're going to say let K be Coco's salary, because we have pieces of information such as Jerry makes twice as much money as Coco, and then Mr. Skivington makes $200 more than Jerry. So those are the pieces of information we need to keep in mind. So we're going to compare everything to Coco. So let K be Coco's salary. Well, if Jerry makes twice as much as Coco, then Jerry makes 2K, and Mr. S makes 200 more than Jerry, so that's 2K plus 200. So all in all, I have these expressions here. I have Coco's salary, Jerry's salary, and then I have Mr. S's salary. So combined together, they make $1,450. I go ahead and solve for my variable K, which ends up being $250. Now we find Coco's salary. So we need to know everyone else's. Well, if Coco's salary is $250, Jerry's is 2 times 250, so Jerry makes 500. Mr. S is 500 plus 200, which would be $700. Jenny works at a ballpark selling peanuts. She is paid $6 an hour plus 50 cents commission for every bag of peanuts that she sells. Find Jenny's earnings if she sells 42 bags of peanuts during a 4-hour shift. Okay, so again, key information, 42 bags of peanuts, 4-hour shift. So we're going to set our variables. We're going to say H is equal to hours, P is equal to peanut bags, and E is equal to number of earnings. So in this case, we're combining $6 an hour plus 50 cents, I wrote that as a decimal, per bag. So 0.5 times each peanut bag is going to equal her earnings. So now I plug in the information that I have, or have been given. I'm given 4 hours and 42 bags. So when I multiply all this out, I end up getting 24 plus 21, and her earnings would be $45. So we're going to try a different way to look at it. How many bags of peanuts, so the unknown is now part of the equation, it's not the earnings, must she sell in order to earn $100 in 7 hours? Okay? So these are the pieces of information that are important as well now. To earn $100 in 7 hours. So if I have my equation that I've set up from up top, E equals 6H plus 0.5P, I know how much we want to earn. We have $100, and I know the time, which is 7 hours. And I need to find the number of bags she needs to sell. So I'm just inputting the information I'm given into different spots in the equation. So then I end up getting 100 is equal to 42 plus 0.5 times P. We're trying to solve for P. I isolate my variables on one side, constants on the other. I end up getting 58 is equal to half, or 0.5 P, which then means I have 116 peanut bags that she would need to sell in order to earn $100 in 7 hours. All right, different example here. Determine 3 consecutive integers whose sum is 135. And that consecutive simply means in a row. So the 3 consecutive integers in a row, and all 3 of them add to 135. So we're going to let x be a number. And then we're going to let x plus 1 be the second number. And we're going to let x plus 2 be the third, because that would be consecutive. X, then x plus 1, and then x plus 2. So now I have my expression x plus 1 plus x plus 2 equals 135, right? That's what it tells us it equals to. All I'm going to do is just collect my variable terms and constant terms. So I'm going to have 3x plus 3 equals 135. 3x is equal to 132. X is then equal to 44, which means that if x equals 44, the next number would be x plus 1 equals 45, and then x plus 2 is equal to 46. So your 3 numbers are 44, 45, and 46.